welcome everyone to this robotics panel. We did have a fancy name for this panel, but unfortunately it didn't make its way to the actual program. But I think robotics panel kind of sums it up. It's nice and simple. Um, so I have some industry guests with me and also some graduating students who are going to talk about their projects, and I'll come on to that very shortly. Um, but I just wanted to sort of clarify this point because sometimes people ask me, well, what has robotics got to do with games? You know, we're site in the middle of a games expo. So I thought I'd just kind of show you some examples. So robots play a really big part in computer games. More in a way as kind of fictional and kind of creative material, a kind of grist of kind of what people are often fighting, battling, or collaborating with robots, and kind of fictional worlds are kind of critical to kind of the way that we perceive robots. In fact, I know there are at least 2 or 3 games in the expo that contain robots. So robots is a kind of important kind of element, but there are also kind of crossovers in between robotics and games. Games are about playing out physics and movement in virtual space, whereas robots are about doing the same thing but in actual physical and real space. So there are definite kind of crossovers, and as students realise, they work with computing students who are designing virtual worlds, and robotics students work with those students on maths modules, which where the requirements are fairly similar. So there is crossover. Um, but the robots of fantasy sometimes quite often are quite sort of distinct from the robots of real life. Um, and many of the robots, I mean, the only robot that most of us probably encounter as a real thing in the real world may be the kind of Roomba kind of vacuum robots, which are kind of common kind of consumer items these days. Or, well, if you've got enough money to have one, they're fairly common consumer items. In fact, I was in a travel lodge the other day and they were kind of going down the hallway cleaning stuff. So I was like, wow, they are coming everywhere. But with robots are generally secreted away in large logistics facilities. The kind of common place where we're seeing a lot more robotics being applied is in kind of warehousing, fulfillment centers, and so on. So some of the examples here in these slides. So there's maybe a slight disconnect between the real world of robots and the fictional one. But robots, so when we talk about this disconnect, I think one of the important things to make this connection between robots and entertainment as well, before I come on to, well, actually, we're talking about that in this actual session, but I just thought it was a very quick thing to touch upon. So here is BB-8 from The Force Awakens, from 2016. Now, sorry, 2015. Now, Disney went away, and Disney are actually quite famous for doing kind of robotic projects. They went away and they built something which didn't actually get used very much in the film because I don't think it worked properly. But they developed a version of BB-8 that was a real robot, and here is the kind of prototype model of it. And that comes from even earlier research that was conducted by this is from a Japanese university, where they developed this kind of dynamic balancing systems in order to control a robot that could be balanced. This is just it demonstrating it sort of with a basketball. But then now you can see it being used to kind of balance on a ball, and then eventually they start putting loads on it and things like this. So what I'm trying to kind of point to here is that the actual hard, heavy engineering and robotics programming is going on here in 2010 at a Tokyo University, and that then evolves through into entertainment. So it evolves into, so the things that are happening in real life are becoming the fictions a few years later. So there's this kind of deep crossover between the two. This is another Disney project, very quickly, which is about, they've been developing this realistic and interactive robot gaze where, I've shown some of this stuff to students, so some of them will have seen it. But it's about developing this really complex subsumption architecture to kind of continuously change and map and match kind of the way humans look at, so these kind of lots of different interacting systems that are kind of working out how to gaze and just to connect with a human, because one of the meaningful interactions that we're always trying to encourage is how do robots interact with humans. That could be as simple as pressing buttons, but it could be also about how robots kind of interact. Are they quite human-like? Although it's got a terrifying face, its eyes are actually quite engaging. You do want to look at it. It's trying to look at you. It's looking away from you, and all these kind of things. So it's a kind of interesting project. I just wanted to make that point between this kind of link between the world of games and entertainment and kind of physical robots. Also, robots kind of occupy this area of our fear and our terror. Many people, I'm sure people have been, if all students who are working in robotics, their parents probably say to them, oh, you're going to take my job away, and all those kind of discussions we have about robots taking over the world. The whole Terminator kind of idea of the robot army. People always say to me, when are you building the robot army? When, you know, this kind of stuff, you know, there's kind of this thing. But it is kind of true, you know, there is always this fear that robots represent this kind of space. There's even a company in Falmouth making robots that look very much like kind of a bit like a kind of Terminator robot, quite realistic, representative of that kind of humanoid robot kind of vision. And so that comes down to this kind of, often it's kind of it's the elephant in the room at the moment. It's about artificial intelligence and about robotics. I often think robotics is, although it involves artificial intelligence, it's kind of a slightly separate discipline. And so, but obviously the fear is always, once you connect the artificial intelligence to a physical being that has agency in the world, then terror can proceed from that. But I always come back and I always show the students this is a really important thing. It's called Morovich's paradox, which is that robotics is hard. We should expect the difficulty of reverse engineering any human skill to be roughly proportional to the amount of time that skill has been evolving in animals. So if it's taken many millions of years for these skills to evolve, it's quite a lot of effort that we have to go through in order to make these things work. Now, that's not to say we aren't making massive achievements in robotics, but it's an important kind of balancing thing for people who are worried that robots are going to come and sort of destroy them at any moment. The oldest human skills are largely unconscious and so appear to us to be effortless. Therefore, we should expect skills that appear effortless to be difficult to reverse engineer, but skills that require effort may not necessarily be difficult to engineer at all. So, you know, we need to think about getting robots to do the things that we don't want to do, things that are hard, things that are, you know, require a lot of effort, but may not require a lot of kind of ingenuity, are things that we need to get robots to do. And I think the cartoon at the bottom is a very good demonstration of this Morovich paradox. So what I want to do is come to the panel now. So on my right over here, we have some robotics graduating students. I'm going to first come to Dan because it's the first picture in the slide. So I wonder, Dan, if you could introduce yourself and then just introduce the project that we're going to kind of expand on in a bit.
Yeah, so I'm Daniel, and I'm a third-year roboticist, and this is our robot group project called Kevin Respace, and it's a omnidirectional robot with a scissor lift on top that would be able to have enough torque to lift up 13 kg, which is enough to carry a chair. And with our comp sci students as well, we were able to get an easy-to-use app to navigate and control the robot. In theory, we should have like a swarm of them, and they'll be able to help conventions set up chairs and stuff.
Thanks, Dan. And the next project on at the far side of the slide, I'll hand you over to Josh, who can explain.
So I'm Josh Beckett. I'm a third year as well in robotics, and this was my dissertation project. It's a underhand exoskeleton for people with arthritis. So most conventional exoskeletons, they drive force through the joints, but people with arthritis, they have sore joints, and that's where the pain actually occurs for them. It's not that they're too weak necessarily; it's that there's pain involved with it. So I developed basically a hand just underneath another hand that reacts based on how your finger flexion moves so that you can grip objects and have more grip strength but cause no pain for people with arthritis.
Thank you. Right, and on the sofa with me, we have two industry guests. So I will start off with Kevin, who sat next to me, and their company, USS, and I'll let you expand on it. So the first three pictures relate to your company.
Thank you very much. My name is Kevin Whittemore. I'm the CTO of Uncrewed Survey Solutions, so I oversee the tech side of our little boats. So what you can see, hopefully, big behind me, we have two different sized vessels there. Both have nobody on board. They're designed to go off and do hydrographic surveys. They're looking at the seabed, and they produce maps like you'll see on the bottom left. Not conventional robots you wouldn't think to look at. They go off and do these things themselves. There's always someone there operating them, but they will happily go off, follow lines, go where you tell them, come back, gathering data the whole way. So we build these boats, we operate them, we deliver data. But the whole thing is driven by software, by basic robotic principles, not so much the AI side. I'm happy to talk about later if you want to. Probably do for me for now.
Yeah, great.
For hours.
And our second guest, who's actually an alumni, this is Harry Saw, who graduated last year.
Yeah.
Last year. And I'll let you introduce yourself and your project, Harry.
Yeah, so like Matt said, I'm Harry Saw, and I work for Holeship at their National Drone Hub, which is based at Lizard at Pradanic Airfield. And what Holeship as a whole does is drone test and evaluation. So people bring their uncrewed aerial systems to us, and they test it in our airspace and in the on the airport and on our equipment there. And so on the right-hand side, you can see one of the main bits of kit we use, which is called SADI. So it's always got to have an acronym, and it's Ship Air Digital Integration Equipment. And the top photo on the right-hand side shows both the truck and the trailer. So on the truck, you can see some big wings coming off it. And what that does is, as you're moving forward into wind across the runways that we've got access to, it develops turbulent air behind, like you would get on the back of a ship. And so that poses a unique challenge when you've got uncrewed systems that are trying to land fully autonomously. And on top of that, just to make it more difficult for them, the deck itself moves like it would on a real ship. So we're able to emulate basically ship limits and operate from there. So, and then the bottom slide there is Certo Airspace, one of our partners who have landed on SADI. And yeah, that's about it for me for now.
Thank you. So thanks everyone for introducing yourselves. So I'm just wondering, I'm going to kind of go back to the students, and I'll just quickly go back to your slide as well. So I wonder if you could, because I think, I'm going to kind of get an industry perspective on this as well, but I wonder if you could talk to us a little bit about some of the biggest technical challenges that you had in terms of building your particular robots. And because I know Josh once said to me only like a week ago, I didn't realise it was so so difficult to build a fully autonomous vehicle. So perhaps you would like to expand on that.
Yeah, I mean, do you want to talk about Kevin first, or?
Well, I mean, the hardest part is like everyone working together and like doing their own bits, but it's just the hardest part is integrating it into one big system and making it all work seamlessly, because it never really does in the first go. So that's the hardest bit. So it's like as long as we start together, it might be better. But it's just putting it all together. That's like the hardest part for
Yeah, it took
the project.
a long time. It's what do you always say about how much time integration is, Matt?
Yes, it's like it's I can't remember. It's a famous Bell Labs thing, which is a project.
15% is 90% of the time.
Yeah, the last 10% takes 90% of the
Yeah.
project,
Yeah.
or something along those lines. So yes,
And that was very apparent with Gavin. But yeah, with my hand, it was more so the technical challenges that I found were in prototyping the materials that are used. It's really hard to make them not just snap into pieces. When I was using an exoskeleton, it has to provide a lot of force for someone, but the force output was snapping everything that I was using. So like the PLA, the TPU, it was tearing through everything. So really for me, that was the most difficult challenge, is the creative solutions you have to come up with to overcome the limitations of the materials you're using. So yeah.
So if I come over to this side, I wondered, because from an industry perspective, could you maybe allude also to some of maybe some specific examples of key challenges, and maybe I think it's kind of useful to students to know, to see what it's like on the other side of the coin. Maybe you've got like some fun stories, some interesting insights.
Yes. No, I think the difference operating as a commercial entity is it's got everything you do has to basically pay for itself.
Yeah.
So, like I say, things break. If you're operating commercially, you can't afford for things to break. Downtime costs money. The other issue we have related to that is we are building very complicated systems, lots of communication. There's small moving parts, and then in our application, we throw it in the sea. Why do that? The worst possible place you can put anything tech, it doesn't work. So making robust systems, not overcomplicating things, you can do that, but if you do it too much, you end up kind of making it non-functional. Suddenly you've got a boat that'll go out, but it doesn't do any work. So finding that compromise between something that can survive, can still do the work, that doesn't cost too much, because if it's commercial, it has to be cost effective. So it's very in a very hostile environment. So it's a different way of looking at it. So if you're building something here as a project, you can afford to make those mistakes. You can afford for your PLA to snap. I can't afford that. So everything is over-engineered from the start. Everything has to be considered. But ultimately, you need that goal of, yes, it can do the job. It can do it well. It does what we say it can do. How you get there, sometimes you do make mistakes. Things go wrong. You learn from that. So always, it's an ongoing process. You do something. Is it doing it as well as it can? Is it doing it at all? And then what can we change? What can we fix? And what impact does that have? So yeah, keep moving.
Yeah, it's very similar with us. It's you've got to get that first solution that is very, very robust and works. And obviously yours are in the sea, ours are being on the Lizard. It's around very harsh environment in the form of sea air, so everything will corrode if you let it. So it's all about that maintenance there again, because downtime costs money, and you've got to make sure that you've got a customer coming in, it needs to work, then it needs to show what it's capable of. And working through iteratively and just starting with something that is bulletproof and then working down, because again, cost comes down into this as well. You can't just have something as bulletproof as possible and then it costs way too much money for a customer to use. So you've got to sort of work out what compromises can be made and what can't, to make sure that it still does exactly what it needs to do, but does it more efficiently and more cost effectively as well.
I think one benefit you've got is if it goes wrong, you're there, you can fix it.
Yeah.
If ours goes wrong, you have to go and get it, and that can be quite a challenge sometimes.
Yeah, no, definitely. Thankfully, ours is just attached to a trailer, and we've got all our telemetry right there. But yeah, we've noticed with some of the customers we've had coming in, going out long distances out to sea. So we've got about 8,000 kilometres squared of airspace that people can use, and sending drones out all the way there, and just trying to maintain that communication uplink, and we're trying to communicate with them as well. And it's quite interesting, quite an interesting challenge sometimes.
So yeah, it was interesting you were saying about water, because some of the students last year were trying to build this submersible, and basically all their electronics eventually just ended up being covered in kind of plumber's cork. They were just kind of squirting everywhere, just trying to waterproof everything.
The poor man's conformal coating.
It was, it was, yeah. So it's quite interesting. But I wonder, you were mentioning, so I think it's coming to my next kind of question is about autonomy, and so I'm kind of interested, particularly with with USS, with whole ship as well, but like about kind of the idea of autonomous vehicles. So one is, to what extent are your vehicles autonomous? Are they remote controlled, or are they autonomous to some degree? And you say that sometimes you lose them, or not say lose them, but you have to recover them. Lose them, maybe. Sorry, that's the wrong. But you have to recover them.
Yes.
So I'm wondering kind of how that kind of whole system works, and kind of how you implement that.
Yeah, it's tricky because the word autonomous is quite a big word. And to answer your question, how do they operate? Yes, it does all of those things. So primarily, we have a boat that you can drive as a radio control boat. Fairly standard drone stuff, forwards, backwards, get it off the trailer, get it to where it needs to be. It then goes remote. So, for example, we did a lot of work towards the end of last year in Nigeria. So our bigger boat was in Nigeria, plying up and down the seas, but being driven from Hale. So 2,700 miles away. All the operations were known on the boat. Everything was driven remotely. There we go. Yeah. So at that point, it's still not autonomous. There's always a trained, effectively a skipper with a commercial driver's ticket sat at the desk, looking at the cameras, driving the boat, telling it where to go, making the decisions. And there's something there, I'll go around it. I need to contact port authorities. All of those decisions were made by a person local to us. Regarding autonomy, we can tell the boat where to go. We can effectively send a series of lines and say, right, go and survey this area. And you can put a grid of lines. Say go, the boat will find the start of the line, follow up and down, and hoover up automatically. We don't go much beyond that. We've looked at other systems. So we have the ability to do things like look at the maritime charts, follow a contour line, so you can't drive the boat over the sandbank, or if another vessel comes into range, it will say, there's a boat in the way, I'll go around that. Now, for our particular application, we are not doing that, and that's actually driven by legislation. So the MCA, Marine Coast Guard Agency, have said, if you're driving your boat here it's not allowed to make decisions itself. It might make the wrong decision. Always have. We've got a train skipper there anyway, making decisions. They do everything. So in a way, it's a bit limiting operating commercially. We can't just say, boat, go and do the things and let it do it itself. There's always someone there.
Because there are strict laws on autonomous vehicles operating off the coast, aren't there?
There are, particularly in the UK. The NCA is quite a blunt instrument compared to some other countries.
Yeah.
But it is, there are prescribed laws. If you're driving in this direction and someone's coming towards you, you have to know what to do. Otherwise, you could have an incident, which is fine. The boat knows those laws. It can do it. But that doesn't necessarily mean that the person driving towards you knows those laws or will do it. If it's someone on a paddleboard just having a jolly, what do? They're just out for the day off the beach. They don't know that they have to give water and move out your way. So it's very difficult having something that knows the laws but doesn't really understand the actual chaotic nature of the operating environment. So it does get troublesome. So have someone there take responsibility, and then certainly take some of the pain away. Not all of it, but makes it a little bit easier.
It's sort of similar actually. So when we have customers coming in who are they wanted to use their aerial vehicles fully autonomously, the strict regulation in the UK does make it quite awkward in that the CAA has got very, very strict regulations on drone. It is slowly starting to ease up and slowly starting to become a bit more modern, but thankfully for our customers, a lot of them are able to do fully autonomous. So they will have a emergency pilot in case something does go catastrophically wrong with the system, but they are able to do fully autonomous. It can track, it can do whatever it wants, because we're able to book out airspace basically and send out NOTAMs and not miles and say no one's allowed in this area. And obviously we check that it's clear first before these systems operate. But that's one of the benefits of where we are for our customers. But because, like you said, the regulation is so strict, it can make it very awkward to do fully autonomous. So recently we've had, off of the back of Sadie, some customers doing fully autonomous landing tests they have a safety pilot there, but they never needed to take control. They were able to land it was roughly 6 meter wide drone on the back of Sadie while it was moving, while there was wind, and it could do that all itself just because we were able to do that, put that safety case forward and to the CAA. Yeah.
How you got, because the principle of autonomy in your which is kind of the aim of where we're trying to get to is a kind of autonomous systems. Because I know there were challenges about localization, SLAM, things like that. I don't know if you want to kind of just talk a little bit about the hard stuff there and kind of how much how much you got there. I know you had remote control, that was all working fine, but where were the kind of...
Yeah. So me and one of the comp sci students, Lewis, we spent a lot of time developing in ROS, so the robot operating system. It's a tool used pretty widely in industry, I believe. And we used a LiDAR, so a laser that spins around really fast, to take maps of the room. So we got it mapping rooms, localizing itself within a room, and then navigating to points within a room. Now, the actual process of doing this was very hard, and the thing is that like you said, with autonomy, because of exterior problems, if everything was autonomous, it would work great all the time because everything works the way that we say it should work. But with noise and people moving around and stuff, with the collision monitoring especially, it was really a struggle to get it to
There's
navigate
like
to
a
a
lot of
position.
cause and effect.
There
It's
was
like
a lot of cause
a
and
lot to
effect.
consider, and
Yeah,
it can't consider every factor.
yeah. So we've definitely noticed that that issue.
Just on a note there, just to complicate things,
Yeah, go.
for our application in particular, we've got a boat that's mapping the seabed, so it's producing those coloured pictures you can see. To do that, we have to move over the seabed at a certain speed very accurately. So we're positioning ourselves within a few centimetres of where we need to be. The problem we've got there is the seabed's not moving. We're moving over the seabed, but we've got this horrible wet stuff in the way, and that moves unpredictably. It moves sometimes slowly, sometimes a lot. It changes direction all the time. So if you're trying to drive over this point and keep your position, you suddenly find that effectively you're driving over that way at quite some speed. And to compensate for that and try and make those calculations and stay where you need to be becomes quite complicated.
Yeah.
Just by adding in that one extra effect, suddenly your robot's got a moving floor. How are you going to position your chairs now because the floor's moving?
Yeah.
So it gets more and more complicated every time you add one more variable into it.
Yeah.
So and how do you resolve that? You can't account for everything. All you can do is react. You can't calculate it out. You can't guess what's going to happen. So that's where things start to get complicated. Hopefully just complicated. Hopefully not go wrong. But it does have a major impact on what you're trying to achieve and how you do it.
Yeah.
Great. So what I've thought is it's for a lot of the, so quite a few people in the room are maybe a year or two off graduating, some are or immediately graduating. So I wonder, it might be interesting coming from you guys, and obviously I know Harry from being at the university, but also I just wondered like what your route to the industry was, how you might sort of give maybe some tips or advice to graduating students about kind of moving into the kind of engineering robotics industry. Maybe sort of, but maybe your own story is illustrative. I don't know.
I would say don't do what I did. It's one of the things. I have never had a clear path through what I have done. I just find myself where I am, which is a bit complicated. So always I've been a tinkerer, taking things apart, fixing things, building things, and I happened to be able to make a career of that. So not formally trained. I didn't go to university. Started off working for a software company. I had an opportunity to start building equipment as part of a European project because I just happened to be in the right place at the right time. Now, one of my benefits, you don't want to hear this, but either one of the benefits I've got is because I haven't followed that conventional path, I don't have to do things the way you've been told to do. I can do what I like. I can make it up as I go along, and I have done a lot of that. So it went from water quality monitoring systems, oil booms. I've done hybrid boats. I've set fire to massive lithium battery banks. I've blown up engines, and it's all exciting stuff. And I always followed the interesting stuff. But along the way, I've picked up various awards for things being, this is the best of its kind. This is the best in the industry. You think, well, that's good. Just strive for the interesting and make it unique is what I've always tried to do. So just give it a go. Don't be scared to break stuff. I've broken so much stuff in the past. As long as you don't have to pay for it.
So there you go. No point coming to university.
No, fully waste time. No, for the sake of it, it's a very good. It's a very good place to be.
But I think it points to it. It's a great. I think that's very useful to everyone here, because I think as everybody who's a roboticist who works in robotics or engineering, we're all people who like to tinker with things, mess around with stuff, blow things up. I mean, the space just outside the lab, the outdoor area, is always students take things out and kind of trying to blow them up or trying to test some chemical or something which they shouldn't be doing. So the one thing about robotics students, they're always doing slightly. We're going, what are they doing out there? Why are they? Why is there some flame over there? What's going on? So there is always that curiosity which we love to encourage, is that kind of tinkering, and because it's such a cross, there are so many disciplines involved. That we really encourage students to do anything. I mean, I've had students who are like sewing things because they need some sort of fabric, so that they're sewing in the lab. There's all sorts of different things that students get involved in an attempt to try and solve a problem. So that's there's some great advice.
But I think personally, if there had been a robotics course near me when I was at your stage, I probably would have done that. But it wasn't. No, there was nothing that interested me to carry on my formal education, so I went and made it up myself.
Good recovery there. Thank you.
Yeah. Did I get away with it?
Harry, I don't know. Do you want to kind of build on that a little bit? Having had some experience of university, how that's led to where you are now?
Yeah, so I mean, I've had a bit more experience at university than most. I went to Plymouth University doing geology back when I was 18, and then found out it wasn't for me, dropped out of that, and then did all sorts of things in the interim, did software development, did hardware development, did everything, just trying to sort of get my foot in the door and meeting lots of new people. And then during COVID, I'd lost my job, and I came back to university in my mid-20s. And sort of finished up in my late 20s, and I was able to find the job I'm in now purely through connections I'd made elsewhere, and without those connections and putting myself out there and just trying lots of different things. I mean, years ago I actually had a week at USS. That was probably 6-7 years ago now, but it's all just through meeting people and all of that, and then putting yourself out there and being up for trying lots of different things and not saying I do robotics, that's all I do. So my role is I'm technical coordinator. I do all sorts. I'm writing documentation. I'm doing actual. I'm liaising with customers. I'm doing actual sort of engineering and robotics and hardware design and software design. Um, I haven't just gone in and said, "Oh, well, my job says I'm doing this. I have to do this." You just need to be open and up for trying anything and being open and honest with your abilities. But like I said, if something goes, when it goes sometimes. Sometimes they break, and you just need to be open and honest and be like, "Look, this isn't my remit, but I'll give it a go." And you learn a lot, and then you're able to apply that later down the line. And having a lot of being able to wear a lot of hats can be quite useful sometimes.
Absolutely. I think particularly if you're an SME, you're small, you don't have the luxury of just doing your job.
Yeah.
So, like I say, I don't see the tech, but I will happily go out and I will drive a sport boat around. I will go and get wet and muddy. I will go to the powder coaters to pick up the metalwork. I will sit there and I will drill holes in things. You have to do all of it because and you can bring a team together, but they will have to do all of it as well. You haven't got the luxury of having your little compartment to sit in, which is why it remains interesting. And I think there does come a point where you can pigeonhole yourself.
Yeah.
Try and keep it interesting because that's where the fun is.
I do think that's a good advantage of SMEs over sort of big companies like primes. You have that flexibility and you do end up learning a lot more, I think, which keeps your job interesting, really. The more you're learning, the more interesting it is for me, really.
Great. So what I did a panel yesterday, and I kind of we talked a lot, and we'd missed out on the opportunity for questions. So I'm going to kind of take this opportunity because we've got a few more minutes left to kind of seek questions, and that obviously we can take questions on the stage as well as in the audience. But I don't know, did anybody in the audience have questions for any of the panel? Would anybody like to? There's a hand there. There's a hand there. Do we have a mic in the? Oh, there we are.
I'm nervous because I recognise the hand.
It's more of a statement actually, and it just relates really to the last bit. So my name's James Williams. I'm the Chief Executive Officer, so the boss basically of USS. Work very closely with Kevin. Just to let everybody know really that we had a student walk through the door. I think it was about a year ago, called Liam, that is a student here at this university. And he just said, I'm actually in marine renewables. I'm interested in doing some summer placement. Have you got anything going? And I took him out the back and showed him what we do. He said, oh, this is great. I said, well, send us our CV, have a chat with Kevin. He then came and worked with us for the summer, and he impressed everybody so much that he actually starts full-time in a couple of weeks' time once he finishes his course. So that point about, get out there, speak to people, don't be afraid, push yourself out there. I was really impressed with the fact that this person just came in off the street and had a chat, and I just happened to be there at the time, which was great. So that the timing worked. But yeah, it's that sort of initiative that small companies really like. And if you can, it's hard to do, selling yourself and pulling up your big boy pants and going out and speaking to strangers that you don't know and you know nothing about. But if you can do it, it is impressive, and it can actually open really good doors for you. So definitely an advocate of that sort of approach. Thank you.
So I think it's great advice. I don't know. Does anybody have any questions for our panel? Oh, must be some.
We're just amazing at just explaining everything.
Hi guys, thank you for that. That was cool. Question for the students, if that's all right. I just wanted to know such cool projects to finish on. What was the main driver for your creations? You spanned the event management space, the sort of healthcare space. What was the driver?
We had like a prompt, didn't we?
So we had a hackathon at the start of the year, and we basically just threw ideas at whiteboard.
Yes. It first became like organizing rooms for like uni students.
Yeah. It was like organizing like studio apartments or something like that. And then we were like, studio apartments are hard. You have
There's a lot of different furniture.
There's so much furniture there. What are we going to move in?
Look at maybe exhibition hall, something like big open neutral spaces.
Then we went to schools, and
then we went to schools, and then schools are hard because of ethics, and we were like, no.
Health and safety.
We don't want to deal with that.
No.
So then it was convention halls because they just have loads of chairs. So that's great for us to sort of target.
But it's nice to like find a solution that like could help a lot of people and
Yeah.
become an actual useful thing. And I think that what drove us was it could actually be useful and it could be an actual
Reducing
product.
labor in some
Exactly.
way. Although maybe small, but the fact is that there are people that just sometimes have to unstack chairs. Like, I mean, the technicians were setting up Expo. They're all really like intellectual people, and they're just setting up some chairs sometimes. That's not really a job that they have to do necessarily.
Yeah.
There can be a simple robot that does that, and that's not one of the things where it's like taking away a job. It can work with people.
With people and empowering staff.
And yeah, it can like it means that they can do the more creative tasks. And then with my exoskeleton, I saw just this gap in robotics with arthritis specifically. My granddad suffers from arthritis, and I was just kind of interested to like start looking at some papers and stuff and see, hey, what are people doing with arthritis? And it turned out nothing really. Um, there's lots of work being done on rehabilitation due to like spinal cord injuries and things like that, but I sort of saw that gap and I was sort of like, how come? Why not? And now I found out why not, and it's because it's hard. It's hard to make something that's not connected to you exactly, it's partially connected, and then interacts with you seamlessly, is lightweight, you can just slip it on. It's a hard challenge and one that I am still plugging away at today. I brought a new prototype of a finger into the robotics booth that people can have a play with. It works by using force sensors instead now, so you can like press it and it will move towards you. But I think really it's just for both of our projects, it was finding that problem and then trying to find a creative solution for that
It's
problem.
like it's just solving problems. Like
Yeah.
we do like solving problems, and like the harder it is, the better. But then
Yeah.
also we become sad. But
We become sad and then it's fine. But
it's fine.
yeah,
But then we get it working.
we get
we're sad.
working, we're happy.
So where do you see it going? Are you looking at progressing it, commercializing it? Do you have an end goal?
With Kevin, we were looking at commercializing at the very start, but the issue is that we were finding it very hard to understand how mass production works.
Yeah.
Because we've nearly got the first, well, I said the first prototype, the first full prototype. This is what, prototype 4 maybe?
Yeah.
Kevin 4. That's Kevin 4.
Kevin Four.
And that was a whole year of work. You know, that was and like
There's a lot more development that needs to be
there's a lot
considered.
more R&D
Yeah.
that needs to be considered. We want to add like some forklifting stuff so that we can. One of our teammates worked on that a bit, so we can like unstack chairs as well.
Okay.
But the amount of R&D we have to do, and then moving on to the production line, the
Commercializing anything's
commercializing,
expensive.
Yeah.
it's
In
expensive,
time
and
and
also
money.
we don't have business brains. We don't
No.
really see how that works. I know China's involved somehow, but
I know that's the biggest understatement of the year. I think China might be involved somehow.
yeah, a little bit. But then with my exoskeleton, I'm going on to a master's next year, and I'm hoping to develop it further and maybe do some clinical testing, seeing how people with arthritis can actually interact with it. But I mean, Dan, I don't know if you had any thoughts about how we were going to commercialize Kevin further.
We need to get a business student.
We need a business student.
Yeah, no, definitely commercializing things are hard, particularly if it's going to be around people somewhat. That
Yeah.
makes it even more difficult because
Yeah.
you've got to have all the safety features there.
Yeah.
Thankfully, Sadie's a little bit different. We can just go. No one's allowed anywhere near that thing when it's moving because each actuator's got a ton of
We have a
force on
big
there.
red
So
button.
Yeah, we have a big red button, so
there we go, sorted. I'm sure that'll go down.
Every safe, as long as you can reach the red button when it's coming
Yeah.
towards you. It's good.
yeah, well,
It
you
might be
know,
running away, but
it-
it's fine.
When the red button fails, that's the problem.
yeah, exactly.
Red button on a stick sticking out in front. Yeah,
Where's the e-stop for the e-stop?
yeah.
Well, I think we are beginning to run out of time. I don't know, is there anybody who's plucked up the courage to ask a question in the audience? No more? Oh, one more. I think we can get one more quick question in. Hi.
I was sort of wondering, because you've obviously focused on specifically your medical area of the hands, and you're working in like the more ships and water side of things. When you're looking at like what projects you want to work on and where you want to focus your career, is it sort of like, do you have a more area, like do you want to go into working in the medical care for like more permanently, or is it more of like you don't really care where you're working as long as you're solving problems?
Do you want to
I mean,
speak on it first?
No, you go.
yeah, I can go a little bit. Yeah, I mean, for me, it was very much I wanted to be solving problems, and I've always had an interest in aviation, which is why I ended up sort of gravitating towards something in that, and then robotics and drones, and it was sort of larger systems than what I tend to be able to do in sort of, well, my loft. It's sort of, you can actually uh, build something quite large, and I think that was my push, was it was just being able to find a job and an area that I was interested in anyway, and then being able to tinker and iterate through things, and that's really my driving force where I'm at the moment.
Yeah, I would say similar. I didn't choose maritime; it kind of chose me. I'm local, and I've lived in this area all my life, and you're surrounded by the sea and boats, and you just can't really get away from them. It's kind of be the shape of the hole I fell into, and that's where I find myself now.
Yeah, for mine, it was I've always been interested in how biology and robots can sort of interact, because they seem like two very separate systems, but we talk a lot about cybernetics in, I think it was second year, um, which is not just robotics, but it's also living systems. Um, and I've always been interested in the combination of biological responses and robotics, trying to maximize human efficiency, I guess. And I've always been into assistive products. While I love autonomy, I I'm really interested in the idea of how we can add semi-automation to things. So, um, for example, like I would talked a lot about in my paper, like the fact that the pension age is rising. So more people are going to be in the industry who are older and tend to have arthritis. So it's about helping that.
I think we probably get. I'm in the red zone, so we probably do. I don't know if you have a final word to say. You get the final word. Dan.
Great. Um, I have like
One word, that is.
I get like it's I get bored really easily, so I like to do stuff different, like different stuff every time. So I just like solving those problems, and robotics kind of let me be everywhere all at once and just start tinkering and just be doing robotics. To be fair, and that's what's great.
Great.
So, like,
Thanks, guys. It's just I did it yesterday and I was getting lots of.
yeah.
So we'll wind up there. Thank you very much, everyone. Thanks for coming. Thanks to my panel. And if you want to talk to everybody, one final thing before I go. At 1 o'clock, we're having a demo of robotics projects at the computing stand in the next studio. So please come along to that. And also, we have an exhibition at Falmouth Gallery of interactive robots, which is on now. It's on all summer, but the opening is actually on Saturday evening. So please come along. I might be speaking to all the people who are already involved in it anyway, but if anybody's out there, please take note. So yeah, 1 o'clock if you want to have a demo of robots. So thank you very much, everyone.